operation is to blot out...
From March 1942 until March 1945, Lancaster crews were briefed for operations against German targets. In all, 56 squadrons of RAF Bomber Command were equipped with Lancasters. Losses were high. Over 4,000 aircraft failed to return. These scenes were shot at Waddington in 1942, when the chance of these young aircrew surviving their tour of 30 operations was only 1 in 3. Outside, among the Lancasters being prepared, is S. Sugar of number 467 Australian Squadron. Sugar, R5868, was to survive 137 operations and is now permanently preserved at the RAF Museum, Hendon. While still operational, Sugar is fueled with over 2,000 gallons of petrol and 100 gallons of oil, and the final preparations are completed for the sortie. The aircrew, volunteers to a man, come from every walk of life and from all over the old British Empire and Commonwealth. Each Lancaster has a 7-man crew: pilot, navigator, flight engineer, bomb aimer, radio operator, mid-upper and rear air gunners. The ground crew plug in the starter batteries to ease the load on the aircraft's internal supply. One by one, the cold engines cough into life. As they do so, the engine-driven electrical generators and hydraulic pumps supply the power to the turrets and flaps. In the late afternoon, the darkly painted night bombers assemble from distant dispersals. Each awaits its allotted place in the complex sequence that will enable up to 30 heavy aircraft to take off from a single airfield. It is achieved in total radio silence, for the enemy is constantly listening. Aldous lamps alone are used. Slowly, the 29-ton bombers are skillfully guided by their young pilots, using brakes and carefully judged bursts of power from the outer engines, from the narrow perimeter track to the long runway. Great care has to be exercised. A misjudgment could put a wheel into the soft grass and disorganize the whole meticulously planned timing of an entire raid. The first bomber takes off, its engine nacelle stained from the leaded petrol. Lancasters tend to turn to port on the takeoff run, the pilots advancing the port throttles to counteract the swing. The rear gunners turn their turrets so that the loaded guns are clear of the aircraft lining up behind them, for the interval between each aircraft is only 30 seconds. After takeoff, the Lancasters form up, flight by flight, squadron by squadron, orbiting near the east coast as they slowly climb in prearranged formations before setting course for that night's target. A major raid takes hours to get going. Far below the cloud, other crews from squadrons on other airfields board their aircraft. These men might be a second wave, briefed to attack a different spoof target to divert the German night fighters from the main raid. By 1944, the almost nightly raids over Germany had become a grim battle of deception. Move and counter-move, with radar plotting every stratagem. The attack is soon underway as Halifax's, Stirling's and Lancasters fly over the target, each aircraft at its planned time and altitude for maximum effect. If an aircraft arrives early or late, it is in hazard from the bombs dropped from aircraft above. The coloured flares of the Pathfinders mark the aiming point, a technique first used by the Luftwaffe over Coventry in 1940, perfected by the RAF over Germany in 1944. Of all the fighting powers of the Second World War, Britain alone perfected the terrible art of concentrated bombing by night. The Lancaster was its most powerful weapon. The first RAF bomber used solely for night operations was the twin-engined Armstrong Whitworth Whitley, which was designed in 1934, entering service in 1937. On the first night of the Second World War, Whitleys flew on Operation Nickel, dropping 13 tons of ineffective propaganda leaflets. Though Whitleys took part in the first bombing attack on the German capital in August 1940, by 1942 they had generally been converted into glider tugs and transports for parachutists. A contemporary of the Whitley was the Bristol Blenheim, used as a daylight bomber, often against German shipping. The Blenheim was inadequately armed and could carry only a 1,000-pound bomb load, though it did have a very good performance, with a maximum speed of 266 miles per hour. In the winter of 1940-41, it was used in a night fighter version, and in this role they pioneered airborne interception radar. Blenheim light bombers continued to operate over Europe, albeit with mounting losses, until superseded in 1942 by Mosquitoes and Bostons. Another pre-war RAF bomber was the Handley-Page Hampden. On the second day of the war, Hampden crews of number 83 Squadron took off to make the first RAF bombing raid of the war, a daylight attack on German warships in the North Sea. The RAF was at the time forbidden to bomb the German mainland on the grounds that factories were private property. Hampdens continued to be used in daylight until the heavy losses due to German fighters forced the RAF to use this poorly armed aircraft for bombing and mine-laying by night. In 1936, there were three new bombers, the Blenheim, the Hampden, and the Vickers Wellington. Unlike the Hampden, the Wellington had a conventional appearance, but its basic construction was far from orthodox. The Wimpy, as the RAF always knew it, used an unusual geodetic construction originated by Barnes Wallis. The airframe, though fabric-covered, possessed remarkable strength, enabling many badly shot-up Wellingtons to return to base. This Wellington, F for Freddy, starred in the very successful wartime documentary film Target for Tonight, which showed RAF night bombing as very efficient, which was, until the arrival of the four-engined heavies, far from the case. Faster than the Whitley and with a better loaded range than the Hampden, Wellingtons were the mainstay of the first phase of the strategic bombing offensive. When they were finally withdrawn from Bomber Command's order of battle in October 1943, Wellingtons alone had dropped over 32,000 tons of bombs on German targets, and many Wimpies continued in other roles until the 1950s. The first true heavy bomber in RAF service was the four-engine short Stirling. This 31-ton aircraft began its operational career on February the 10th, 1941. Stirling was flawed, mainly due to the insistence of the Air Ministry, when the bomber was specified in 1936, that its wingspan be restricted to under 100 feet, so that it would be able to enter the then standard RAF hangars. The result was a service ceiling of only 16,500 feet. Another unforeseen limitation was a divided bomb bay, which prevented the carrying of bombs over 4,000 pounds. But Stirlings took part in the Great Night Offensive against Germany until September 1944, and the survivors performed heroically as glider tugs on D-Day and later over Arnhem. The next four-engine bomber to enter RAF service was the Handley-Page Halifax. It could never equal its contemporary, the Avro Lancaster, in sheer bomb lifting, but it played an important part in many night raids over Germany from 1942. It was designed to a specification which called for a heavy bomber powered by two of the then-new Rolls-Royce Vulture engines. Anticipating difficulties with these 24-cylinder, untried power plants, the Handley-Page company prudently revised the design on the drawing board to accept four proven Rolls-Royce Merlin engines. Production was soon underway, following the successful first flight of the prototype late in 1939. Once in service, the early Halifaxes were found to be underpowered and subject to fatal uncontrollable spins, particularly at low airspeeds. But 6,176 Halifaxes were built. They dropped over 250,000 tons of bombs and later served with both transport and coastal commands. The Avro Manchester, the Lancaster's immediate predecessor, was designed by Roy Chadwick to the same 1936 specification as the Halifax. Before the war, when the Manchester had been ordered for the RAF, service airfields were just that, grass fields. To assist the new heavy bomber to become airborne, the Manchester was stressed for frictionless takeoff, and Farnborough actually tested a prototype catapult, although it was never used operationally. The prototype Manchester originally had a twin-fin tail, but the early flights revealed a marked directional instability. The second prototype shows the characteristic central third Manchester fin. Manchesters entered squadron service in November 1940. They were powered by two Rolls-Royce Vulture engines. This complex power unit was to prove to be one of the very few engines produced by Rolls-Royce which were unsatisfactory. Not only did the Vulture fail to produce its design power, it was also chronically unreliable. Manchester losses from engine failure exceeding those from enemy action. The Avro design staff believed the basic Manchester airframe was good. The simple remedy was to replace the engines. The problem was that Rolls-Royce were, by the end of 1940, fully committed to the production of the Merlin, which powered the Spitfire and the Hurricane. They simply did not have the time or resources to develop the radical Vulture into a reliable engine. The main trouble was a failure of the big end bearings. The Vulture was basically two Rolls-Royce V12 Peregrine cylinder blocks joined to a common crankshaft, and the inevitable teething troubles of such an engine proved greater than anticipated. It is likely that Avro's chief designer, Roy Chadwick, was told as much and advised to seek alternative power plants. The problem which Handley-Page had foreseen was simply solved. Roy Chadwick modified the Manchester wing to take four tried-and-tested Rolls-Royce Merlins. The result was the four-engine Manchester 3, soon to be renamed Lancaster 1. The prototype was built very quickly, since apart from a revised center section, it was practically a standard Manchester airframe. The first prototype, BT-308, showed great promise, the only major modification recommended being a revision of the tailplane. The second prototype, DG-595, having the true definitive Lancaster long-span twin-fin tailplane, as fitted to later Manchester 1As. By October 1941, the first production Lancaster was rolled out of the Avro factory at Woodford. The aircraft, L7527, like the next 299 Lancasters, had started on the production lines as a Manchester. The neatly cowled merlins on the extended 102-foot wing and the pleasing proportions of the Lancaster gave no clue as to its hasty improvisation. A great tribute to the Avro design style. It was clear from the enthusiastic reports of the Avro and Boscombe Down test pilots that the redesign from Manchester to Lancaster had transformed the aircraft in every way. Few warplanes were to require less modification during their successful service life. The test pilots and their civilian crews must have found testing Lancasters a pleasant change. Bill Thorne, Avro's chief test pilot, had made no fewer than 5 forced landings testing Manchesters. The Lancaster introduced to the RAF a new crewman, the flight engineer, and did without a second pilot, partly because of the increasing problems of finding pilots, but also a tribute to the forgiving flying characteristics of the aeroplane. After a successful test flight, the first production Lancaster comes into land at Woodford, the Avro factory airfield, symbolically passing a parked Manchester. Roy Chadwick and his staff had designed a superb warplane. It was a complex aircraft. Each one required 10 tons of aluminium alloy and 55,000 identifiable parts, constituted into 31 major sub-assemblies, which were constructed at dispersed locations under the control of several factories. The Avro workforce at its peak consisted of 40,000, nearly half of whom were female. Women who'd been hastily trained to undertake skilled work that most of them had never contemplated before the war. Britain, unlike Germany or the United States, had compulsory labor direction for women during the war, and in spite of blackouts, severe food rationing and air raids, they averaged, as did the whole Avro workforce, over 66 hours a week of hard manual labor. Each Lancaster required 500,000 manufacturing operations involving a wide range of skills. The 4 main fuselage sections were built separately. This made it possible to bring them by road from Cheddington to Woodford, 18 miles away. Here they could be assembled, the miles of electrical wiring connected, and the wings, with their 4 merlins, married to the complete fuselage. Engaged in the work was not only the parent firm, Avro, but also Metropolitan Vickers and Armstrong Whitworth. Later, Victory Aircraft in Canada also produced Lancasters. In all, 7,377 were to be built. Basically, there were only 3 marks. 1 and 3 were virtually indistinguishable, but the 2s, a small batch of 300, were powered by Bristol Hercules air-cooled radials as a safeguard against a shortage of Rolls-Royce Merlins. The Hercules was fitted as a complete unit with all its systems to simplify servicing and replacement. This Mark II was flying with a bomber development unit. Most operational 2s were flown by the Royal Canadian Air Force. There were 2 reasons for the Lancaster's success. It was capable of lifting a load equal to its own weight, and its unobstructed bomb bay enabled a wide variety of ordnance to be carried. The bomb bay below the main spar and astride the aircraft's centre of gravity measured 33 by 5 feet. In it were 15 strengthened points from which bombs could be suspended. A typical load was a 4,000-pound cookie, surrounded by general-purpose demolition bombs or incendiaries. Or the bay could be filled with 250 and 500-pounders. Alternatively, 6 1,500-pound parachute mines for use against land or sea targets might be carried, or 1 8,000-pounder and 6 500-pound general-purpose bombs. From precept to practice, bombs fused and live are towed from the dumps to the aircraft. Each train is a single bomb load for a single Lancaster, usually weighing about 12,000 pounds, or nearly 5.5 tons. The bomb carriers, which contain the electrical release mechanism, are fitted to 1,000-pound general-purpose bombs. The WAF tractor driver seems to have total confidence in the armourers, though there were fatal accidents during bombing up, several British and American bombers being destroyed. This typical 1,000-pound high-explosive bomb has a small windmill on the tail, which will arm the bomb as it falls from up to 22,000 feet. Carefully, the final bomb is winched up into the Lancaster's bomb bay. The entire stick will be dropped in a precise sequence, each individual Lancaster's bomb load being integrated with those of the other bombers in the raid for maximum destructive effect. High explosive was usually followed by incendiaries. Lancasters alone dropped over 51 million of them. Here, incendiaries are being loaded into SBCs, small bomb containers. While some aircraft are being bombed up, on others, routine maintenance goes on. There were over 400 maintenance checks, mostly conducted out of doors in all weathers. Wartime aircraft only went into the hangars for major work. It required many trades to keep a squadron operational. The armourers work on the Fraser-Nash turrets. In nearby huts, WAPs carefully pack the parachutes. Meteorologists release balloons to ascertain the wind strength and direction. The observations from many airfields were collated to make the most accurate forecast possible, but Met was as much an art as a science, and costly mistakes were inevitably made. A WAF tractor driver tows a Lancaster back to dispersal. The square markings on the starboard wing show where the dinghy is stowed. Each Lancaster required an immense effort to keep it operational. The 7-man crew, the flying control officer and 2 WAF assistants, a WAF parachute packer, the oil tanker with its driver, the 2,500-gallon petrol Bowser with 2 airmen, the bomb train with a WAF driver and 7 armourers, up to 8 ground flight mechanics, a further 7 specialists. Lastly, the Met man, altogether 40 skilled men and women. In 1982, a sole Lancaster remains on RAF charge, the only airworthy example in the world. PA-474 was one of a batch of 235 Lancasters delivered from Vickers Armstrong between April 1943 and September 1944. Though marked as an aircraft of number 617 Dambusters Squadron, PA-474 was never used operationally. It was issued to number 82 Squadron for photographic survey work over Africa in 1948. It then went to Flight Refueling Limited, and probably survived because it was later used at Cranfield for airflow research, flying with a high-performance wing section fitted to its fuselage like an additional fin. Now named City of Lincoln to commemorate the association of Lancaster squadrons with the county of Lincolnshire, it is maintained at RAF Coningsby to fly as a memorial to the many Bomber Command crews who did not return. What was it like to fly and fight in a Lancaster during World War II? This film, shot in 1944 at RAF Hemswell, and the 2 aircraft preserved today, give us some idea. The crew positions. Firstly, the pilot, who, irrespective of his or his crew's rank, was the captain. Close by him, his flight engineer, who was usually informally trained by the pilot to fly the Lancaster straight and level. The navigator, who also operated the new radar aids. The wireless operator, who was responsible for all RT and WT communication. The bomb aimer and the gunners. By far the loneliest and most dangerous crew position was the rear gunner's, tail end Charlie. His vigilance and quick reactions could save the aircraft from night fighter attack, either by warning his pilot to take evasive action or by direct defensive fire. This number 1 group Lancaster has the perspex cut away for clearer vision and is armed with twin 0.5-inch guns for greater hitting power than the standard Fraser-Nash rear turret with its 4 303-inch Brownings. The turret is very restricted, though it did rotate as a complete unit. The control bar with the triggers operating the firing and movement of all 4 guns. The 4 breech blocks alongside the gunner enabled him to cock the guns and to clear any stoppage if he had time. In an emergency, the turret could be hand-turned to allow the gunner to escape. The vital oxygen supply for the turret, like the rest of the Lancaster, was unpressurized. The gunner would therefore be on oxygen for the whole trip, endlessly quartering the night sky. The supply rails lead from 4 ammunition boxes placed nearer the aircraft's center of gravity. The boxes contained 1,900 rounds, the rails an additional 600, a total of 10,303 rounds for the rear turret alone. Above the ammunition tracks, the trimming control wires, and below, the main elevator and rudder actuating rods, both vulnerable to shrapnel damage. In front of the tail spar, the Elsan lavatory with its accessories. From the rear turret to the mid-upper, not quite so exposed as the rear, but like it, cramped, though it's only armed with 2 guns. The bags catch spent cartridge cases, which could otherwise roll round the fuselage and jam vital equipment. The turret had what was called a gun taboo, which tracked the guns clear of the aircraft's tail fins. The mid-upper gunner couldn't wear a parachute in his turret, so had to stow it and retrieve it when required. Once in his turret, there he remained for the whole trip, unless ordered by his captain to leave. The aircraft was vulnerable to attack from below, a weakness quickly exploited by the Luftwaffe night fighters. The mid-upper gunner's original purpose was to defend the aircraft against beam attack, but although his field of fire was excellent, the turret became increasingly less important. The flight engineer replaces the gunner's step as he and the pilot make their way to the cockpit, checking one of the escape hatches. The Lancaster main spar ran through the center of the fuselage to leave the bomb bay below unobstructed. This enabled the Lancaster to carry enormous bomb loads, but it put a major obstacle between the crew and their forward positions or their means of escape. Behind the main spar, 2 compressed air bottles, and underneath the step, the accumulators, which maintain essential electrical services until the engines start. Just in front of the main spar, the wireless operator sat before his TR-1154-55 high-frequency radio. Wartime bomber radio operators didn't use their transmitters very often, since doing so could reveal the aircraft's position. Vari lights were a simple alternative, a method of visual communication, colors of the day identifying friend from foe. But the 1155 receivers were used for operational signals, a selection of aerials being available for long-distance communications. Any transmissions were by Morse code. The receiver had a direction-finding facility from a loop aerial, which the navigator could use to obtain fixes from known radio beacons to check his position. But like star fixes taken with a sextant, the method was never easy and often unreliable. A far more precise navigation and bomb aiming aid was the radar H2S, seen in this once most secret instructional film. The aerial scanner, mounted under the fuselage, rotated, sending out a continuous stream of ultra-high frequency radio pulses. Flat ground and calm water returned no echoes, though buildings or high ground did. The navigator, watching his cathode ray tube, was thus presented with a moving map of the terrain below. Unfortunately, the H2S transmissions could also be used by the Germans to track the bomber. So an alternative passive navigation aid, codenamed G, was also used, which simply picked up pulse signals from transmitters in England, enabling the navigator to plot his position on special charts. Though due to the Earth's curvature, G's maximum range was about 200 miles. Ahead of the navigator, the pilot straps in, helped by his flight engineer. The disc behind his head is the only armor plate provided for the Lancaster crew. The cockpit of Sugar, with the simple blind flying panel, then common to all RAF aircraft. To the right, the rev counters and boost gauges for the 4 engines. Flying controls for this heavy bomber were manual, not power-assisted. The throttle, mixture, and propeller controls. The P6 magnetic compass was only for standby because of the unpredictable deviation caused by the iron bombs. A remote reading compass being the main. Its sensor unit was well aft, away from the influence of the bomb load. The flight engineer turns to his control panel, mounted on the starboard side of the cockpit. He was responsible for the fuel management, these controls enabling him to pump fuel from tank to tank, to balance the aircraft, or, in an emergency, to transfer fuel from a damaged tank. The standard fuel tanks on Lancasters were in the wings. Number 1 tank, 580 gallons, number 2, 383 gallons, and number 3, 114 gallons, divided port and starboard to give 2,154 imperial gallons in all, sufficient to place most of German-held territory within Lancaster range, which varied with the load carried, but could be as much as 2,700 miles at reduced power. Fuel contents, engine oil, and coolant temperatures were the main responsibility of the flight engineer. The bomb aimer, later called bombardier, was also the front gunner, but his main function was to locate the target indicator flares and to aim accurately using his stabilized bomb sight. The bomb aimer's call of "bombs away" must have been eagerly anticipated, especially when he added "no hang-ups," because with an empty bomb bay, the returning aircraft could be subjected to violent evasive action. Defensive countermeasures of another kind were also carried. The large aerials on this Lancaster's fuselage are for the secret jamming transmitter, codenamed Airborne Cigar. And after its bombs have gone, the aircraft drops bundles of foiled strips to confuse the enemy radar further. Other special loads included 2 4,000-pound cookies joined together to make a single 8,000-pound blast bomb, or the 12,000-pound, 21-foot-long tall boy, which required some modification to the bomb doors. The most impressive was the Grand Slam 22,000-pound earthquake bomb. Tall boy and Grand Slam were the work of Barnes Wallace, whose most original weapon was undoubtedly the bouncing dam-busting mine, also carried exclusively by Special Lancasters. The epic attack on the Mearn and Ada dams by 617 Squadron's Lancasters was reenacted in a famous feature film. Grand Slam was used in the later stages of the war in daylight attacks on hardened targets. Some 30 Lancasters were modified to carry it. The size of this, the largest operational non-nuclear bomb ever dropped, is apparent. This is the first such attack, that on the railway viaduct at Bielefeld in March 1944. The massive bomb achieved supersonic speed to bury itself deep in the earth before detonating, creating a local earthquake, shaking down the target. Only 41 Grand Slams were dropped. Though most of their service career was as night bombers, Lancasters from the summer of 1944 took part in many daylight raids, supporting the Allied ground forces in the land battles, particularly around Caen, with accurate tactical bombing. Although by then the Allied air forces had secured air superiority, heavy flak claimed many aircraft, including this Lancaster, ablaze and out of control over Normandy, while its bombs detonate below. During the war, Lancasters dropped 608,613 tons of bombs, 51 million incendiaries, and over 12,000 mines on 156,308 sorties. The last flight of an RAF Squadron Lancaster was flown by RF 325 on October the 15th, 1956, to a maintenance unit to be scrapped. 12 years before, when operations against the Japanese were still probable, to prove that Lancasters could fly vast distances, this modified version, PD-328, later named Aries, flew round the world testing long-distance radio and navigation aids. A post-war airliner role for the Lancaster seemed feasible to Roy Chadwick. The weightlifting power of the Lancaster wing and engines was attached to a new capacious fuselage. Longer and deeper than the Lancaster, the York needed a third fin, harking back to the original Manchester. Although used as a VIP transport, the York's most famed role was as a freighter during the 1948 Berlin airlift. RAF Yorks alone made 29,000 flights. Because of their ease of loading, Yorks seemed to carry most of the city's coal. It's said that when years later the Yorks were finally broken up after long civilian use, coal dust was found in their innermost recesses, a legacy of the Berlin airlift. The York was a relatively simple transition from the original Lancaster, and though usually powered by 4 Merlins, it could, like the Mark II Lancaster, also fly with Bristol engines. In September 1943, the Lancaster was again redesigned by Roy Chadwick, this time to an Air Ministry specification which had called for an enlarged Lancaster, capable of operating at up to 35,000 feet. The aircraft was designated Lancaster 4. The general outline of the new bomber followed the original design, though it was larger and heavier. Eventually, it was to receive a different name, Lincoln. The prototype first flew from Ringway on the 9th of June 1944, though the type did not achieve squadron service until 1945. SX-937 is a Lincoln II, seen here just after the war. Lincolns were soon to be supplanted as frontline bombers in the RAF, though they operated in Malaya and against the Mau Mau terrorists in Kenya before being replaced by jets. The Lincoln has the distinction of being the last piston-engine bomber in RAF service. While that later Avro aircraft was replacing the surviving Lancasters, many of those still flying were used for test beds, like this Mark II with a Whittle jet in its tail. Thus, a basic 1936 design, which was nearly a failure due to its inadequate engines, was proving a form of propulsion which would power almost all future aircraft, military and civilian. 2 Lancastrians, descendants of the Aries, were used by Rolls-Royce to test fly their Nîmes jet. This engine, flying on VH-742, was to influence engine designers the world over. It was to be produced in greater numbers than any other, and was the first truly modern jet engine. VH-742 was the first Lancaster to be jet-propelled, just 10 years and a world war away from the original Manchester specification. city of Lincoln, the only surviving airworthy Lancaster, spends the summer months flying around the country with the RAF Memorial Flight. Keeping a 40-year-old bomber serviceable is not easy, but its Merlins, perfectly maintained, start without difficulty. The City of Lincoln's devoted crew and maintenance personnel hope to keep it airworthy until the next century, by which time, if they succeed, it will have outlived most of the surviving aircrew who flew Lancasters on operations during World War II.